19 of Advent of Code. I missed it last night due to preparing to travel, but I've got a couple hours before I get to catch my flight. So let's hope that I can finish this in time, because I've got basically exactly 2 hours. So we'll see how that goes. Alright, so let's dive in. Let's see, I've done the setup, so I'm going to go ahead and prepare to take an input, and I'm also going to open up the template file that I have set up here. And then we'll go look at the problem description. Okay. Oh. This is using day 16's opcodes. Cool. Cool. Instruction pointer can be bound to a register. There are now 6 registers. So I've not bound to the instruction pointer behave as normal. Yep. Okay, we always increment the instruction pointer after any instructions may have modified it. Starting from its 0 next, yep. Let's see. Values of the 6 registers after encode after running it. Yep. The value of the instruction pointer. Cool. Okay, that's not an instruction. Yep. Okay. What is left in register 0 when the program halts? Okay, great. So let's get our input. And the instruction pointer is always 5. Oh, I am having a suspicion that maybe this puzzle is going to require writing this into pseudo-assembly, or writing it into a Go program rather than actually interpreting it. But let's go ahead and paste this in. And we're actually going to need to insert some stuff from our day. What was our day puzzle? It's day number 16. Okay. So let's pull in a bunch of that code that I'll actually need. Okay, so instructions are still 4 wide. No, they're not. Instructions are no longer 4 wide because of the fact that we have this as a string rather than an integer. Okay. So we'll need to modify that around, which is fine. Let's see. And then we're also going to need to have the operation that's being performed. Okay, something like that should do the trick. We don't need the op registry. We don't need the list of ops because we know what all of these are now. Okay, great. So we've tested all of these. We know that those work 100%. So now we do need to have the mapping of each of these things to each of these things. Let me turn the volume on my headset because it's obnoxiously loud. And I can't actually hear myself. There we go. Now I can actually hear myself. Cool. Let's see. Okay. Yep, so we have all these. We have our, now we have, there are now 6 registers. Sure, that sounds reasonable. Okay. Okay, now, just going to clear all of this boilerplate out of the way. I don't need that. Okay. So that is still going to be the core of what we're doing. Right. We don't need the line to match opcodes to their int codes because we now know what's what. Okay. Okay. That seems fine. Okay. Okay, so we're going to have something that maps opcodes to their ops. I think, can we define a map statically? Can I initialize a map with I don't think I'm allowed to statically initialize. Yeah, okay. Well, that's unfortunate. Fine. Fine, we'll do it the annoying way. It's a little annoying, but I'll stick with it. GTRI. Okay. Cool. Alright, So I'm going to assume that my input always starts with the instruction pointer line. Okay. Okay. Cool. And now we need to read the instruction. Okay. Let's see. Okay, that's still fine. It's not self-modifying, so that actually was fine. All right. Okay, that's okay. Make sure, yeah, ops is fine. That's okay. That seems okay. Alright, I'm just going to comment this out and make sure I can parse everything successfully before I continue. So let's run that. Okay. Strings and strconf. Okay. Instruction has no method f, but instruction has a variable named f. Oh, whoops. There we go. Lines and IP bridge. Oh, yeah, I don't need that anymore. Okay, great. Now, all right. That seems fine. Okay. So now that is still correct. Instead of using 0, we use I.f runs on that. Okay. So it runs in the registers. We still take our operands. Yep, that's fine. Okay, that looks okay. Okay. So now we no longer execute the instructions in order. So, instead, this is what we need to do. Wait, Go has map initializers? Oh, thank you. Where? Oh. Thank you. That's super helpful. Okay, let's redo that. Yeah, thank you. Thank you, thank you, thank you. Okay, so now we're going to need to redo that, but that's fine. Sorry, did I do this like a peasant? Okay. Okay. Yep, much cleaner. Much cleaner, much cleaner, much cleaner. Okay. Okay. Wonderful. That shows what I get for not looking at Twitch chat for a moment. Okay. Morning, Necro Buffalo. Alright, so yep, that should be fine. Okay. Okay, and now we are going to feed in. Okay. Taking int. Oh no, that still takes that. Yeah, okay. That's easier to rewrite here once. I think I can do this. I think that'll be the right thing. There are now only 3 operands, that's right. Okay. That's 6. Yep, that seems fine. Okay. And now the deal is okay. I think that should do it. Cool. Oh, that's disappointing. That doesn't quite work. Alright. Not quite smart enough to do what we want. IP reg declared and not used. That's a lie. I did in fact use it. Oh. Alright, let's try that. That is correct. Alright, part 2 now. This time register 0 starts with the value 1. Okay. Now I suspect this will essentially run forever. Yep, that is in fact effectively going to run forever. Okay, so instead we're going to have to decode this input and figure out what it does rather than running it by hand. So I'm going to check in what I have. Okay. So now let's look at this code and try to understand what it is doing. So we're going to copy day19.input instead into a Go program. And we're going to have a look at what it's doing. So the instruction pointer is 5. So let's have a look here. In fact, I now know that I'm going to have to stare intensely at this, and if I'm going to stare intensely at it, I want it closer to me, so I'm going to, yeah, we'll do that. No, I actually don't like doing that. Yeah, let's do this instead. Something like that should do the trick. Okay, good enough. All right. And that's going to clip off the edge of my screen just due to how the projector is set up. Okay. Let's maybe also make a new profile that is bigger and also has inverted colors.